We have now mounted a small laser scanner on the EPUG robot, and in this lecture we will explain how these kind of devices work and how they generalize to a larger class of range-finding devices. For that, let's have a look at the website of the Webots LDS01. This is a very simple device. You can see from the price it's around $200, and it has a small motor that actually physically rotates the laser setup. And when you look at the specs, you will see that it can sense from 12 centimeters to around 3.5 meters, where it has an accuracy of around 1.5 centimeters. And it does this at around 300 RPM. So RPM are rotations per minute. That means when you divide this by 60, you get the rotations per second. And so this device rotates around 5 Hertz. I'd like to note that in Webots we assume this device to be much faster. We are actually using it at the rate of the time step, which is 32 milliseconds. In practice, these devices are much slower, and 5 Hertz is really on the low end. When you pay more, you will get a much faster spinning laser that spins at around 20 or 30 Hertz. We also see here that this device can sense around 360 degrees, so it goes all the way around in a circle at an angular resolution of 1 degree. This means we have 360 data points 5 times a second. Now, how does a sensor like this work? So we have this animation here from Wikipedia page of the LiDAR sensor, and what you can see is there's a rotating mirror that has a laser pointing down on it, and whenever the mirror is outside the working range of the laser scanner, the laser spins, it scans the objects, and we get measurements. And to the right you see the resulting point cloud, which yields points on the walls, eventually on the circle here, and then finally the right hand wall. The laser scanner is one of the oldest sensors. It has been developed for security applications, mostly by the company SICK in Germany, and it has been used to protect people from walking into machinery and really creating what is called a safety curtain. Roboticists have quickly adopted this sensing system to put it on mobile robots and create maps of the environment. But we have now much more powerful devices that can scan not only one dimension but in 2 dimensions, and they are known as rangefinders. There are many different devices. In Webots they are abstracted as a rangefinder device, and you can see a demo here. The robot drives around and you see what is called a range image in the display, where the gray levels depend on the distance to the object. So as the robot goes closer, the objects become darker, which means that they're closer. You see this again here. This far ahead wall was gray, light gray, now turns dark. And you can also discern all the elements like this block in the environment, or here these other blocks. So these sensors have been really revolutionary, and what you see here is an idealized version. You can actually go and change the noise in the Webots simulator, and we can do this here and set it, let's say, to 0.1. And now what you see is a noisy image where the different points have slight noise. And when you remember the laser scanner that we just looked at, the noise was around 1.5 centimeters. We can increase this to make it more realistic, but in practice you will find that the noise dramatically varies with the surface that you are looking at and the technology that you're actually using. For example, laser doesn't work very well on glass surfaces. Stereo vision requires textures. So in this example, stereo vision wouldn't work very well because we cannot really find matching pairs, and this is something we will explain in a later course in this specialization. And most recently, people have started to work with radar, mostly driven by the car industry. where a radar is used to create a range image of that nature.